The problem that Milgram came up with uh, goes as follows. Milgram, suggested that given any two people in the world, person X and person Z, how many intermediate acquaintance links are needed before X and Z are connected? Milgram states there's two different philosophical views which are relevant to this question, but ultimately this is an important empirical question. One view argues that any two people in the world, no matter how remote from each other, can be linked in terms of intermediate acquaintances, and that the number of such intermediate links is relatively small. A second view argues that any two people in the world will never link up because people have circles of acquaintances which will not necessarily intersect. For instance, a message will circulate in a particular cluster of acquaintances, but it may never be able to make the jump to another cluster. Milgram, in one of his articles, talks about the famous urban sociologist or urban studies scholar, Jane Jacobs, who recounts a game that she used to play with her sister called Messages, where as little girls, they would pretend that they had to send a message on to some random person in some other part of the world through, by contacting somebody that they knew on a first name basis. And Milgram actually took this idea and did a number of different experiments to see just how far people were from one another in terms of social distance, in terms of social network chains. Now, one of the things to consider is that each one of us has a certain number of ties to other people or to alters. And this is one of the things that social network scholars think about. But typically, we have at least 1,500 to 2,000 weak ties. People that we know at least as acquaintances, and each one of those people knows at least 2,000 people, and each one of the people that those people know knows at least 2,000 people. And if you think about it geometrically, it turns out people are not so far distant sociometrically as we intuitively think. So as a thought experiment, I'd like you to spend a few moments and think about, how distant are you, socially speaking, from the Queen of England? And when I say socially speaking, let's say you had to pass on a message, an envelope, a message in an envelope, and you could only pass it on to people that you knew on a first name basis, and they could only forward the message to someone that they knew on a first name basis. How many intermediaries would there be between you and the Queen of England? Now, I think at first blush, most of us would think, wow, that must be like a really long path, right? Because, most of us don't travel in royal circles. And, you might think it might be hundreds, might be dozens or hundreds or even thousands. But I would wager that for many people, it's not nearly as far as you think it would be intuitively. So if I think about it myself and I think about this problem, I can think, well, there's a few Canadian politicians that I've met in one context or another that I know on a first name basis, and they know Justin Trudeau, and Justin Trudeau knows the Queen. So in my case, there's probably only two people separating me from the Queen. Now, that doesn't mean I'm buddies with the Queen, but it means in social network terms, I'm not that distant from the Queen. So let's think about some basic social network concepts. And again, some of these were raised in the readings that that I suggested that you take a look at. So this will give us an opportunity to kind of refresh your memory in some cases, or maybe add a little bit more knowledge about some of these things. So one of the most basic notions in social network analysis is points or nodes. These are sometimes referred to as vertices as well, and these are the basic social units in a social network graph. So this is a graph of one of the graduate courses I taught at one point in time. And here you can see there's a variety of shapes, a number of triangles, and at least one square, and a few circles. These represent the individuals who were in my class. And the lines or ties in the graph represent the relationships between the nodes in the graph. So this might be, for example, a graph indicating who communicated with whom, or maybe who gave advice to whom in the class. Now we can use network graphs to depict all kinds of things. So this is a network graph of the famous cartoon family, The Simpsons, and looking at parent-child relationships. And I would guess that most people in the class could have drawn this graph themselves. Now, social networks and social network graphs don't need to be applied just to individuals. They can be applied to social units at various scales. So, for instance, here we have a graph of nation states, and the relations are world trade in manufactured goods. And so here the arrows are showing, trade going from one nation state to another nation state, and the size of the nodes show the number of different ties that they have. So the larger the node, the more trade that country is doing. Now, in social network analysis, we can think about the ties as being directed or non-directed. So in other words, we can think about the nodes as being senders or receivers, but sometimes we can also depict social networks as being non-directed. And in that context, there's no distinction between the sender and the receiver. So an example of a directed tie might be Gary gave a present to Mary. An example of a non-directed tie might be Susan talked with Joan. They just communicated. Another important distinction is the distinction between whole networks and ego networks. So whole networks refer to the pattern of ties amongst all the nodes in a bounded social network. Ego networks refer to the pattern of ties radiating out from particular individuals to a set of alters. And my slides went backwards somehow. So now we're looking at a graph of a set of individuals in a juvenile gang. So this data was collected by Stephen Barron in the context of an ethnography that he did in British Columbia. And here the individuals in this gang are indicating the people that they hung around with the most. So this is an example of a whole network. It shows all of the ties amongst all of the individuals with everyone else in the network. Now let's focus on this one person named Ben. And now we're going to take a look at Ben's ego network. So this is an example of an ego network. We're not looking at everyone in the gang. We're just looking at Ben and the people that are directly tied to Ben, and then the ties amongst Ben's alters, right? And so this is, as I said, an example of an ego network. Social network data can be represented in graph form or matrix form. So on the left we have a graph, and on the right we have a matrix. Very often the data is represented as zeros or ones, 1 representing the existence of a tie and 0 representing the absence of a tie, but there's other alternatives as well. So sometimes ties can be valued. Another important distinction is the difference between one-mode versus two-mode networks. So a one-mode network is a network where, if you think about it in graph terms, the units in the rows and the columns are the same types of units. So for instance, we might have a square matrix of students by students, or protesters by protesters, or directors by directors, or individuals by individuals. In a two-mode network, we have two different types of actors. So in a matrix, we have one type of actor along the rows and a second type of actor along the columns. And so some examples of two-mode networks here are students by classrooms, protesters by protest events, directors by company boards, individuals by voluntary organizations. And so we can think about this in a slightly different way. You know, another term for one mode networks are square matrix, because if you have a one mode network, then by definition it's square. These are also sometimes referred to as adjacency matrices. By contrast, we can think about two mode networks as rectangular matrices, because typically there's a different number of rows than there is columns, and these are also sometimes called incidence matrices. So here we'll use another example. We have a set of actors who are women on the left, and then we have a set of events that these women attended as the columns in this matrix, right? And so if there's a 1, so for instance, the first actor's name is Evelyn, and for the first event, Evelyn attended the first event, Laura also attended the first event, but Teresa has a 0 in column 1, so she did not attend the first event, and so on. So again, going back to thinking about COVID, we could think about events as foci or settings, right? And these could be places where individuals might interact and might potentially be susceptible to becoming infected with the coronavirus if there was somebody who was infected. So this is an example of a two-mode network in a graph. So here we have the red nodes, which are the women, and the blue squares, which are the events. Now, one of the things that's interesting from a social network perspective is something that Ron Breiger refers to as the duality of individuals and organizations. So we can think about individuals, in this case, being linked through events. So for instance, Olivia and Dorothy both attended event 9. So in a sense, they're indirectly connected through event 9. But we can also think about events as being connected through individuals. So for instance, Flora attended both event 9 and event 11. So we can think about event 9 and event 11 as connected through Flora. And it turns out they're also connected through Olivia. In political economy, social network researchers have looked at things like the boards of directors and looked at the extent to which pairs of directors serve on multiple company or corporate boards. And in that sense, we can think about corporate interlock. We can think about the directors as connected to one another through these boards, but we can also think about different corporations as connected to one another because they share pairs of directors. Again, in the context of coronavirus, we can think about these as settings. So if we think about the sociological science article by Weed and Cornwell, instead of the blue squares being events, we could think about them as classrooms. And we could think about these as individual students as being connected through classrooms.